In a remarkable convergence of lunar observation and ambitious space exploration plans, NASA is making significant strides in both Earth science and its future missions. Recently, the agency's efforts have been highlighted through two pivotal developments: the successful deployment of the Airborne Lunar Spectral Irradiance air-LUSI instrument and the confirmation hearings for billionaire entrepreneur Jared Isaacman as NASA's new administrator. In March 2025, NASA pilots undertook a series of night flights over the Armstrong Flight Research Center in California utilizing the agency's ER-2 science aircraft, which transformed into an airborne lunar observatory. Equipped with the air-LUSI instrument, the aircraft soared nearly 70,000 feet above the Earth's surface, where it measured the sunlight reflected off the Moon at various phases and wavelengths. This unprecedented capability allows scientists to use the Moon as a calibration tool for Earth-observing sensors, enhancing the accuracy of measurements related to weather patterns, vegetation growth, and ocean conditions. Kevin Tuppy, air-LUSI's principal investigator from NASA's Goddard Space Flight Center, emphasized the importance of these measurements, stating, "As an absolute reference, the Moon also becomes the perfect benchmark for satellites to consistently and accurately measure processes on Earth." The data collected during these flights marks a significant advancement in Earth observation technology, potentially reducing costs associated with satellite missions by minimizing the need for onboard reference devices. The air-LUSI project is a collaboration between NASA, the National Institute of Standards and Technology, the U.S. Geological Survey, and several universities, including McMaster University in Ontario. This collaborative approach highlights the growing synergy between various scientific disciplines and institutions, fostering innovation in aerospace technology. Meanwhile, on the political front, Jared Isaacman's nomination as NASA administrator has garnered considerable attention. During his confirmation hearing on April 9, 2025, Isaacman articulated a vision for NASA that aligns with President Trump's ambitious goals of returning humans to the Moon and preparing for crewed missions to Mars. He acknowledged the critical role of the Artemis program, which aims to establish a human presence on the Moon, particularly in light of growing competition from China. Isaacman's background as a billionaire entrepreneur and private astronaut positions him uniquely to lead NASA during this pivotal time. He has previously commanded the Inspiration 4 and Polaris Dawn missions, and he conveyed his commitment to advancing both lunar and Martian exploration. "NASA is an extraordinary agency that can do the near impossible," he stated, asserting the agency's ability to pursue multiple objectives simultaneously. However, concerns remain regarding potential shifts in priorities and the agency's reliance on commercial partnerships, particularly with SpaceX. As the Senate prepares to vote on Isaacman's confirmation, his leadership will be tested by pressing challenges including budget constraints and the ongoing evolution of the Artemis program. The agency is navigating a complex landscape where funding uncertainties could impact its ambitious timeline for lunar missions and subsequent endeavors to Mars. With nearly 30 astronauts expressing support for his nomination, Isaacman may have the backing needed to steer NASA through these turbulent waters. In conclusion, as NASA continues to refine its Earth observation capabilities through innovative projects like air-LUSI, the agency's future direction under Jared Isaacman's leadership will be crucial for maintaining its competitive edge in space exploration. With ambitious goals set for the Moon and beyond, the coming months will be pivotal in determining how NASA adapts to challenges and opportunities in the ever-evolving realm of space science and exploration. The International Space Station (ISS) continues to be a hub of groundbreaking scientific research and breathtaking observations, as evidenced by recent activities and discoveries aboard the orbiting laboratory. As the Expedition 72 crew prepares for upcoming missions and research endeavors, their work highlights both the challenges and wonders of space exploration. On April 10, 2025, NASA announced that the Expedition 72 crew is focusing on innovative cardiovascular research aimed at understanding the effects of microgravity on human health. Notably, the crew is investigating how space travel impacts head and eye pressure along with the dynamics of blood flow and weightlessness. These studies are crucial as they may provide insights into the health risks astronauts face during long-duration missions. An increasingly important consideration as humanity prepares for potential journeys to Mars and beyond. Understanding these physiological changes is essential for ensuring the safety and well-being of astronauts on extended missions, explained a NASA spokesperson. In addition to their scientific contributions, the crew welcomed new members aboard the ISS. NASA astronaut Johnny Kim along with Roscosmos cosmonauts Sergei Ryzhikov and Alexei Zabritsky successfully docked at the ISS on April 8, 2025 after a swift journey from the Baikonur Cosmodrome in Kazakhstan. This arrival brought the total number of residents on the station to 10, a temporary increase that will last for 2 weeks. Kim marks his first spaceflight experience while Ryzhikov and Zabritsky bring their respective expertise to the mission. Their arrival sets the stage for Expedition 73, which will officially commence on April 19, 2025. Following the departure of 3 crew members who will conclude their 7-month scientific mission. In a captivating display of nature's beauty, NASA astronaut Don Pettit captured stunning footage of a vibrant green aurora over Earth on April 5. With over 370 days spent in space and extensive experience conducting research and maintaining the ISS, Pettit frequently shares glimpses of life aboard the station. The ethereal auroras, which result from charged solar particles colliding with the Earth's atmosphere, serve as a reminder of both the fragility and majesty of our planet. Seeing these phenomena from space is truly magical, Pettit remarked, reflecting on the profound experience of witnessing Earth's natural wonders from such a unique vantage point. As the ISS continues to host critical research and stunning observations, the implications of its activities extend far beyond the confines of low Earth orbit. The ongoing cardiovascular studies may lead to breakthroughs in not only space medicine but also in the broader field of healthcare. Furthermore, the diverse crew and their collaborative efforts underscore the importance of international partnerships in advancing our understanding of space and its effects on human physiology. Looking ahead, the ISS remains a cornerstone of human space exploration, with future missions poised to build on the knowledge gained through these current endeavors. As the crew members engage in their scientific research and prepare for the challenges of extended space travel, the world watches with anticipation for the next chapter in humanity's quest to explore the unknown. NASA's Perseverance Mars rover is currently making significant strides in its exploration of the Jezero crater, where a remarkable diversity of rock types is offering scientists an unprecedented look into Mars' geological history. Since its arrival on the red planet over 4 years ago, Perseverance has been diligently analyzing the crater's rim, revealing insights that could shape our understanding of past life on Mars. In a mission characterized by rapid scientific discovery, the rover has cored 5 rocks since January, successfully sealing samples from 3 of them into sample tubes. In addition, it has conducted detailed examinations of 7 rocks and analyzed another 83 from a distance using laser technology. This accelerated pace of data collection represents the fastest tempo of scientific activity since Perseverance's landing, underscoring the wealth of geological diversity present in the area. Perseverance ascended the western wall of Jezero crater for approximately 3.5 months, reaching the rim on December 12, 2024. The rover is currently investigating a 135-meter high slope, informally dubbed Witch Hazel Hill. The findings have exceeded the expectations of the mission team, as the variety of rock formations has proven to be far richer than anticipated. During previous science campaigns in Jezero, it could take several months to find a rock that was significantly different from the last rock we sampled and scientifically unique enough for sampling, said Katie Stack Morgan, the project scientist for Perseverance at NASA's Jet Propulsion Laboratory. But up here on the crater rim, there are new and intriguing rocks everywhere the rover turns. It has been all we had hoped for and more. The geological significance of the crater rim is profound. It features fragmented rocks that were forced to the surface by meteor impacts billions of years ago, juxtaposed with well-preserved layered rocks believed to have formed during Mars' earliest geological period. Among the samples collected, Silver Mountain, obtained on January 28, 2025, is particularly notable, as it likely originated over 3.9 billion years ago during the Noachian period. This rock may have undergone alterations due to ancient impacts, making it a vital piece of the Martian geological puzzle. Another intriguing discovery was made at an outcrop containing igneous minerals, which are excellent indicators of geological processes. Although initial attempts to core this rock were unsuccessful due to its crumbly nature, Perseverance's journey to another site known as Tablelands yielded a successful sample, although sealing it presented a unique engineering challenge. The team employed multiple techniques, including a flick maneuver, to ensure a proper seal on the sample tube, demonstrating the innovative approaches necessary for such complex missions. As the rover continues its exploration of Witch Hazel Hill, it has already analyzed additional rocky outcrops, including Sally's Cove and Dennis Pond, to further enrich the mission's findings. Looking ahead, Stack emphasized the promise of more discoveries, stating, "We still feel that Witch Hazel Hill has more to tell us." Perseverance's mission is not solely focused on geological exploration, it also aims to search for signs of ancient microbial life, thereby contributing to our understanding of Mars as a potential habitat. This mission is part of a broader initiative including the Mars Sample Return Program, which plans to bring Martian materials back to Earth for detailed analysis. The ongoing discoveries from Perseverance are significant not only for their scientific value but also for their implications for future human exploration of Mars. As the mission progresses, the data collected will inform not only our understanding of the planet's past but also the potential for sustaining human life on Mars in the future. With each new sample, we are one step closer to unraveling the mysteries of the Red Planet and understanding our place in the universe. NASA's Perseverance Mars rover continues to unveil the secrets of the Red Planet as it explores a remarkable array of rock formations along the rim of Jezero crater. Since reaching the crater's rim on December 12, 2024, the rover has embarked on an intensive geological investigation, revealing a wealth of information that could reshape our understanding of Mars' history and its potential for past life. The rover's operations, which began in earnest this January, have resulted in the coring of 5 distinct rocks along the crater rim, with samples successfully sealed from 3 of them. Perseverance has also conducted detailed analyses of 7 additional rocks and examined another 83 from a distance using its laser technology. This pace marks the most productive science collection phase since Perseverance's landing over 4 years ago, showcasing the mission's ability to gather significant data rapidly. Katie Stack Morgan, the project scientist for Perseverance at NASA's Jet Propulsion Laboratory JPL, expressed her excitement about the findings, stating, "During previous science campaigns in Jezero, it could take several months to find a rock that was significantly different from the last rock we sampled. But up here on the crater rim, there are new and intriguing rocks everywhere the rover turns. It has been all we had hoped for and more." The rocks of Jezero's western rim are particularly fascinating because they include fragments of ancient molten rock, likely ejected by meteor impacts billions of years ago. This geological diversity not only provides insight into the planet's tumultuous history but also raises questions about its potential habitability. Among the standout samples is Silver Mountain, taken from a rock believed to have formed over 3.9 billion years ago during Mars' Noachian period, a time marked by significant geological activity. Perseverance's sampling efforts have not been without challenges. For instance, the rover faced difficulties in sealing the Green Gardens sample from the Tablelands rock due to the powdery nature of the material. Kyle Kaplan, a robotics engineer at JPL, described the intricate process involved in achieving a successful seal. "For Tablelands, we pulled out all the stops. Over 13 sols, we used a tool to brush out the top of the tube 33 times and made 8 sealing attempts. This meticulous effort paid off, allowing Perseverance to store a serpentine-rich rock sample that could hold clues to ancient microbial life." As the mission progresses, the rover is set to continue its exploration of Witch Hazel Hill, where it has already analyzed additional rocky outcrops including Sally's Cove, Dennis Pond, and Mount Pearl. Stack emphasized the importance of these ongoing investigations, stating, "The last 4 months have been a whirlwind for the science team and we still feel that Witch Hazel Hill has more to tell us." The Perseverance mission is not only pivotal for its scientific discoveries but also plays a crucial role in paving the way for future human exploration of Mars. NASA's Mars Sample Return Program, in collaboration with the European Space Agency, aims to retrieve these carefully collected samples from the Martian surface and bring them back to Earth for detailed analysis. Meanwhile, in the political sphere, the nomination of Jared Isaacman as NASA administrator by former President Donald Trump is stirring discussions about the agency's future direction. In a recent Senate confirmation hearing, Isaacman articulated his vision for NASA, which includes advancing both lunar and Martian exploration initiatives concurrently. He emphasized the need for the United States to maintain its competitive edge in space exploration, particularly in light of China's ambitions. As Isaacman prepares to lead NASA, he faces the challenge of balancing the ongoing Artemis program aimed at returning humans to the Moon with the ambitious goal of sending astronauts to Mars. "We don't have to make a binary decision of Moon versus Mars," he stated, reinforcing the notion that both objectives can coexist within NASA's strategic framework. Looking ahead, the convergence of Perseverance's groundbreaking discoveries and the evolving leadership at NASA suggests a promising trajectory for American space exploration. As the agency seeks to reclaim its position in the global space race, the findings from Mars could provide vital insights not just into our neighboring planet's history but also into the broader quest for life beyond Earth. The next few months will be crucial as both the rover continues its exploration and Isaacman navigates the complexities of space policy and international competition. NASA's recent activities have showcased the agency's commitment to advancing space exploration and Earth sciences, marking a pivotal moment in both lunar navigation and the future of interplanetary travel. In a series of developments, NASA has not only enhanced its observational capabilities through innovative technologies but has also set ambitious goals for human exploration of Mars under the leadership of its new nominee for agency chief, Jared Isaacman. In March 2025, pilots operating NASA's ER-2 aircraft embarked on a unique mission that turned the high-flying plane into an airborne lunar observatory. The Airborne Lunar Spectral Irradiance air-LUSI instrument was tasked with measuring sunlight reflected off the Moon's surface. This groundbreaking endeavor aimed to utilize the Moon as a calibration tool for Earth-observing sensors, helping scientists refine measurements related to weather patterns, vegetation growth, and ocean conditions. Kevin Tuppy, the principal investigator of air-LUSI, emphasized the Moon's role as an absolute reference, allowing for consistent and accurate monitoring of Earth's processes. The air-LUSI project, which involved collaborations between various institutions including the National Institute of Standards and Technology and McMaster University, promises to significantly improve data accuracy and reduce costs associated with satellite operations. Simultaneously, the LuGRE mission launched on January 15, 2025 aboard the Blue Ghost lander, exemplifying NASA's push towards lunar navigation using Global Navigation Satellite Systems (GNSS). This historic mission aimed to determine the viability of Earth-based GNSS signals for navigation on the Moon. Successfully landing on March 2, 2025, the Blue Ghost made history by being the first U.S. commercial lunar lander to touch down upright. The LuGRE payload demonstrated that combined GPS and Galileo signals could effectively support navigation on the Moon, breaking world records for signal tracking and positioning. This capability is crucial for future lunar missions as it promises to enable autonomous navigation for astronauts and robotic systems, enhancing mission safety and efficiency. Against this backdrop of technological advancements, Jared Isaacman, a billionaire entrepreneur and commercial astronaut, is poised to lead NASA under President Trump's administration. During his confirmation hearing, Isaacman outlined an ambitious vision for the agency, emphasizing the importance of returning humans to the Moon while preparing for crewed missions to Mars. American astronauts will lead the way in the ultimate high ground of space, he stated, echoing the president's call for a renewed focus on space exploration. However, his remarks also highlighted potential conflicts with existing plans, particularly the Artemis program, which aims to establish a sustainable human presence on the Moon by the end of the decade. Senator Ted Cruz expressed concerns about the need to maintain a steady course with the Artemis program, warning that shifting priorities could cede ground to China in the ongoing space race. Isaacman assured the committee that he does not foresee a binary choice between lunar and Martian exploration, suggesting that NASA could pursue both avenues simultaneously. He emphasized the agency's capacity to tackle multiple ambitious goals, a sentiment that aligns with the pressing need for a robust U.S. presence in space. As NASA continues to innovate and push the boundaries of space exploration, the implications of these developments are profound. The advancements made through the air-LUSI and LuGRE missions not only enhance our understanding of Earth and the Moon but also lay the groundwork for future interplanetary travel. Isaacman's leadership could usher in a new era for NASA, one that balances ambitious goals with the pragmatic realities of budgetary constraints and international competition. Looking ahead, the intersection of technological innovation and strategic vision will be critical for NASA as it navigates the challenges of space exploration in the coming years. The successful integration of GNSS technology for lunar navigation and the continued calibration of Earth-observing sensors through lunar observations may very well define the future of how humanity explores both the Moon and Mars. As the agency adapts to an evolving landscape, the collaboration between public and private sectors, as exemplified by the partnerships forged in the air-LUSI and LuGRE missions, will be essential in realizing the dreams of interplanetary exploration.